Good fucking morning. Hello, welcome to another stream. How about that? How about that? How about that? Welcome, welcome, welcome. Hello, Aguduk. Hello, Skarsha. Hello, Mustafa. Hello, Mr. Botka, Fedi96, Trash5. I hope you exercise today, otherwise I'm gonna ban you. Hello, hello, Nafli. Hello, hello. What's oh, okay, so we don't really have that many. You didn't exercise. Okay, Instaban. Fucking Instaban. Gone. Only exercised people in the chat. Rotten Chonzi, hello, hello, welcome, welcome, welcome. So, Takio, hello, hello, welcome. So, today is Saturday, and that means today, according to the schedule, we are doing a game development in C++. But since right now is advent of CODE, first we need to solve one advent of CODE problem. That's what we'll have to do first. And today is going to be the day 10. I know I'm lagging behind. This is because I'm waiting for everyone to post their solutions so I can steal them. So, and yeah, this is what we're going to do today. Hello, Sokram1337, welcome, welcome, welcome. Okay, so yeah, first we're gonna do advent of CODE. I'm gonna use this today. I'm gonna use C, right? And we'll see how it goes. About that. Funny puns, funny puns. Alrighty, so let me start Timux. So let's go to the advent of CODE repo. By the way, you can find my repo here. Yeah, so it's sodding/AOC 2020, right? And I need to probably fetch the latest changes. Let me actually check, because sometimes I clean up the repo off screen, right? I just, you know, clean up some readme and maybe refactor the code a little bit without altering the solution. So that's why I need to fetch the latest stuff. All right, so let me see. So I'm gonna start my Chromium and open the problem, advent of CODE. I'm not sure if I'll be able to solve this problem today, so every time I start a problem, I've never read it before, actually, so I have no idea if I will be able to solve it at all. So maybe that one is going to be the last one, and I'm going to stop solving advent of CODE and get depressed, because I'm so dumb. We'll see, we'll see, we'll see. But before we fall into depression, I think we need to create a boilerplate. Boilerplate. I don't know. Okay, so let me start Emacs. I just prepare some code for the C solution, for the solution in C. So first of all, of course, we need to include everything that is important for a regular C program. All right, and usually how I solve, I iterate through all of the files through all of the arguments, command line arguments of the application, I treat them as files, and I run the solution for each individual files. Each individual file, not files. Anyway, so let's start with 1 because we need to skip the program name, and we're gonna iterate until argc, and then we're gonna do solve file and like this. So we also have to create a special function called solve file, const char file path, and we're gonna just stop this thing. Input file %s file path. Alright, and I need to create a make file so I can build all of this stuff. So it's going to be main.c. So we're going to use just a generic C compiler that is provided by C environment variable. So maybe I'm going to also use C flags, why not? And there we go. So what kind of C flags we want to enable? So I'm going to enable all of the warnings, maybe some extra warnings just in case, right? So I'm also going to use C11 standard, and I also want to be pedantic to make sure that I'm programming in C and not in something else that GNU forces us to program in. And let me see if I can even compile this entire stuff. I cannot compile pedantic. Oh my god, why am I so dumb? Pedantic. Alright, thank you very much. Alright, so and I also want to create a phony target for testing everything. So that phony target is going to depend on the executable itself and a bunch of input files that we're going to have in the future. So right now we don't really have much. So pedantic, yeah. Very funny. Ha ha ha. Alright, and we're also going to have something like sample. So usually I also run my solutions on both my actual input and the samples that are provided in the description of the problem. I think it's kind of useful just to double check everything. And if I try to just run this entire thing, yeah, it actually recognized my solution here, and there we go. We have our boilerplate ready to fight. Okay, so I'm clicking on this day 10, and let's read the description. It's a little bit long, but probably because of the input. It feels a little bit long, but yeah. So, adapter array. Patched into the aircraft's data port, you discovered weather forecast over a massive tropical storm. Before you can figure out whether it will impact your vacation plans, however, your device suddenly turns off. Its battery is dead. You'll need to plug it in. There is only one problem. The charging outlet near your seat produces the wrong number of jolts. What is jolts? What the fuck is jolts? Okay, it's like volts, but with J. It's like a volts for JVM. Is that what it is? Okay, so wrong number of jolts. Always prepared, you make a list of all of the joltage adapters in your bag. Hello to Step, welcome to stream, by the way. Hello Bill Janul, just Jalal, hello everyone who joined. Each of your joltage adapters is rated for a specific output joltage, your puzzle input. A trio jolt is rated for a specific output joltage. Okay, so alright. Any given adapter can take an input 1, 2, or 3 jolts lower than its rating and still produce its rated output joltage. Hello, John. Hello. Hello, Gnolex. Welcome. I really hate this word for some reason. Like, it's so difficult to pronounce. Jolts. Joltage. Alright, so lower 1, 2, or 3 lower and still produce its can take an output. Alright, in addition, your device, but can it take the exact amount of jolts and produce the exact amount of jolts? Maybe it's not important, we'll see. In addition, your device has a built-in joltage adapter rated for 3 jolts higher. Alright. Then the highest rated adapter in your back. Okay, if your adapter list were 3, 9 and 6, your device built-in adapter would be rated for 12 joules. Treat the charging outlet near your seat as having an effective voltage rating 0. Since you this is a horrible description, like I'm reading it and I'm falling asleep, like since you have IOC description seems like they come up with the problem first and the little story later. Well, I mean, have you ever participated in competitive programming? Because that's always the case. Treat the charging outlet near your seat and have an effective voltage rating 0. Okay, since you have some time to kill, MonkeyOS, you might as well test all of your adapters. Wouldn't want to get to your resort and realize you can't even charge your device. If you use every adapter in your bag at once, what is the distribution of the voltage difference between the charging outlet and the adapters and your device? For example, suppose that in the bag you have adapters with the following voltage ratings. Okay, maybe I want to add that to the sample. Is the real challenge is to get to the end of the description because it's painful. Okay. With these adapters, your device built-in voltage adapter would be rated for 19 plus 3, 22 joules. 3 higher than the highest rated adapter. He looks so young. Who are you talking about? The voltage adapter? Anyway, hello, pouring hot tea on your face. Welcome to the stream. Okay, because adapters can only connect to a source 1 to 3 joules lower than its rating. In order to use every adapter, you would need to choose them like this. Okay. The charging outlet has an effective rating of 0 joules. So the only adapter that you could connect to it directly would need to have a voltage rating 1, 2 or 3 joules of this. Only one you have is an adapter rated 1 joules. Okay, I already see the P. Fuck's sake. Alright. So from your 1 joule rated adapter, the only choice is your 4th rated. From the 4th joule adapter, the adapter rated 5, 6 are so invalid choices. However, in order to not skip any adapters, you have to pick the adapter rated 5 joules difference of 1. Okay, similarly, the next choices would need to be the adapter rated 6 and the adapter rated 7 with differences of 1 and 1. What do we maximize something? So, if you use every adapter once, what is the distribution of voltage? Okay. Okay, so this is, they basically describe the algorithm. Do I need to read that? Okay. In this example, then using every adapter, there are 7 differences of 1 joule and 5 differences of 3 joules. Here's a larger example. In this larger example, okay, so this is going to be a sample 2. So we're going to have sample 01 and sample 02 txt. So the problem is that so far I don't understand what do they want from us. Okay, okay, cool. We can chain the adapters. We can chain them. I get it. What exactly are we trying to find? Like, what exactly? Or if we knew what exactly we're trying to find, it would be a spoiler, right? It's one of those problems, I suppose. Okay, in this example, when every adapter, there are 7 differences of 1 joule and 5 differences of 3 joules. Ah, okay. So, would be rated okay. Well, if you use every adapter in your bag at once, what is the distribution of voltage difference between the charging outlet and the adapters in your device? Okay, here's a larger example. In this larger example, in a chain that uses all the adapters, there are 22 differences of 1 joule and 10 differences of 3 joules. Find a chain that uses all of your adapters to connect the charging outlet to your device and count the joule difference between the charging outlets and the adapters and your device. What's the number of 1 joule differences multiplied by the number of 3 joule differences? Jesus fucking Christ! Oh my god, this is the most boring shit I've ever read in my entire life. I wanna die. Really. Okay, I kinda get it. So, and let's take a look at the input. How huge is the input? How huge is the input? So that will affect what kind of like solution we're gonna come up with. So this is gonna be that, and 100? Fucking really? 100? Jesus Christ, seriously? That shit could be perforced. You could have put it in the description or something, like, I mean, come on. Alright. So, fucking 100. But to be fair, I still don't understand what they want from us. I still don't understand what they want from us, so... have you been diagnosed with cancer? No, I've not. But hello, Isengrim. If you're curious about my hair, we have a special comment for that. So, all right. So let me see. So maybe we're gonna start by just reading the numbers. I don't know. I kind of wanna, you know, do something like n, and let's just do 1000. So, and the numbers are relatively small. Exercise is gonna be 0. Okay. So, I'm gonna zero it out, and we're gonna start reading from the file. So, let me open file, open file path, and we're reading that file. And at the end of that file, we want to actually close it after we're done reading it, of course. Why is he not using evil mode? Who are you talking about? Like, you guys keep talking about somebody, like he. Who are you talking about? I have no idea. So I wish I knew who you're talking about. Alright. So, by the way, we don't have indication of how many things they're talking about me. They're talking about you, I see. By the way, can we do just fgets? Can we do fgets in this particular case? Fgets. That would be cool. But for fgets, you need like an internal buffer and shit. So something like scanf would be a little bit better, like I mean fscanf, where you could just read a particular file. Right, so while some condition is true, I don't remember which one. Maybe we can use f end of file, right? F end of file, right? So FOF test the end of file indicator. Okay, so while not end of file, we're gonna try to read a number from here. Exercise, exercise, exercise. And then we're gonna do exercise plus 1. There we go. And then, yeah. So I'm not sure if it's gonna read everything correctly, because I haven't read like files like in a textual mode in C for quite some time already. So let's try to do something like this. Let's print like a red D lines, D numbers. So I just want to see how many numbers it read, and we're going to provide exercise, how many of them it read. And let's just run this thing. So it read 12 files. We do not indicate what input file we're actually reading. So input file, yeah, exercises. We're talking about exercises. Have you exercised today? If you didn't, you're going to be banned. Okay, so in the sample 01, we have okay, so apparently we have 12 of them, which is incorrect. So in case of the sample 2, we have 31, but we have 32, so we have one more, usually, probably because of some sort of a fucky-wucky. So if you read the last one, I wonder, like fscanf, let me try fscanf. What does fscanf returns? So what is the return value? The value is if the end of the input is reached. This function returns the number of input items successfully matched and assigned. Okay, so we can try to count the amount of successfully assigned things, and we can read the x into here. Then we're gonna do access plus plus exercise x, but only if n is equal 1, right? Only if n is equal 1, because this is exactly how many elements we want to read here. And I think that's gonna work. And I think it did. So we read exactly the amount of numbers we expect here. That's actually pretty cool. Haven't seen C since the university. Well, sounds like your fault. So, because, yeah, why didn't you see since the university? Why? Because you can literally just go to GCC, like to Google up GCC, download it, and just use it. Nobody stops you from using C. So, all right. Now, let's continue. So let's actually introduce like a separate function, part 1. And this is where we're gonna do all of that. So read and numbers. Okay, and then after that, after we read everything here, write and see, write and see, write and see, oh, write and see. Pascal's not the answer. Write and see. Sorry. Hilton Potts triggered me again. Okay. I ran out of my... no, I didn't. Everything's okay. Cool. I still don't understand what they want. So, find a chain that uses all of your adapters to connect the charging outlet to your device. Okay, so all of my adapters. Isn't like using all of my adapters essentially just sorting them in order? Yeah. Okay, so if I if I look at this thing, so here's the sample one. All right, and in the sample one, I'm gonna just queue sort this entire array. Let me try to do that. How do you queue sort? So it's gonna be queue sort base. So the queue sort is gonna be a QS. The amount of members is QS size, and the size of a single member is size of QS0. So, and we need to have a comparator function. So let's do something like compare ints, right? And compare ints accepts a const void x, const void. To be fair, we are programming in C, which means that we can just use it like that and just easily cast the functions to the different point. Alright, so, and essentially what I can do here, I can just take this minus this, and that will work. So here it is, here is the comparator. By the way, do they provide like a comparators for us? I think they don't. I think they actually don't, unfortunately. So we have to write our own comparators. Imagine higher order functions in 2020. God damn it. Alright. So essentially this is going to be just... from the first joint. Yeah, essentially it's gonna be. So I suppose it guarantees, right? It guarantees that you can use all of them. Otherwise, it's just impossible to solve. All right, so we're gonna sort them, and I want to actually go through all of these things and just see. Their sizes and stuff, their values, I mean, it's gonna be D. Okay, so here they are, and I want to see the differences between them. I want to see the differences between them. So what's the best way to see the differences between them? I suppose it's to start with that and do minus I minus 1. So that's this is funny. They are exactly 1 or 3. And if I take a look at okay, so essentially they guarantee you that the differences are going to be only 1 or 3, because I didn't see any other differences here. So okay. Well, I mean, it's the first part. Like, people say that second part is gonna kill me from the inside. All right. So, and what they're asking, what's the number of 1 joule differences multiplied by the number of 1 joule differences, of 3 joule differences? Okay. Let's do something like 1 and 3. Right. Cool. And we're gonna put it like that. And I'm pretty sure I'm doing something incorrectly, because I don't know if I have to include the difference between the outlet and the first one. So I'll probably have to do something like that. But first I'm gonna just see if they produce the expected result. So if this one is 1, what we do 1 plus 1, break. Case 3 is going to be 3 plus 1, break. Otherwise, assert, unreachable, and we're going to include assert. Okay, that's it, I guess. And so what do we do with them? Multiplied by the number, what's the number of 1 multiplied by the number of 3? Okay, and that means we might as well actually return that. It's gonna be printf, and no, not printf, 1 multiplied by 3. Cool. And when we're solving a file, so this is essentially what we can do. We can do printf part1 d. So I'm pretty sure this is incorrect. Okay. So what's the intended result of the first sample? So in the example, when using every adapter, there are 7 differences of 1 and 5 differences of 3. 7 by 5, right? 7 by 5, I'm pretty sure is 35, but I actually got 24. So this is already incorrect. Because we probably have to include the differences between the outlet, right, between the outlet and the device itself, and the device itself is 3. So I have an interesting idea. Apprenticeship as an application developer, I don't understand anything here, but it's just reassuring to watch this stream. Well, I'm not sure if it will reassure you, but I'm unemployed. Sorry. So let's actually start with that. So I'm gonna actually add this thing, like the outlet and the value of the device to this to the input as well. Right. Oh shit! And we'll have to probably do that. Yeah, we'll probably have to do that afterwards, after we've sorted everything. I feel like we'll have to sort everything anyway, so let me actually put it here. Oh shit, oh for fuck's sake. Refresh the page. Chat, refresh the page. Refresh the page. I'm really sorry, by the way. Refresh the page. Can you hear me? Can you see me? Chat, can you see me? Are we back? Oh shit, you cannot see me. Okay. Let me restart my chat arena. But the stream should be back. The stream should be... Okay, so we are back. I'm really sorry. That was not my fault, by the way. That was not my fault. My internet was up. I just got disconnected from Twitch. Something with the Twitch. So I'm really sorry, by the way. So I hope it is not really that annoying. Nuffly, refresh the page. Jesus Christ, Nuffly. No F. You should refresh the page. Okay, so let's continue. I'm gonna include the 0 here, and also we're gonna, you know what, I kind of want to introduce the scope here to indicate that like this is where we read the file. Whatever, I think it's a waste of time. All right, and after that, access size size plus 1 should be access size should be equal access size minus 1 plus 3, right? Because the next one after that is 3, if I understand correctly. Jewels had and the highest rated, because after the sorting we're gonna the last one is gonna be the highest rated, right? So this is how we're gonna have that. So at the beginning we're gonna have 0, and at the end we're gonna have the device itself, and maybe that will give us the expected thing, and it didn't. Congratulations, I'm super happy about that. All right. All right, let me bring my tea. And by the way, why do I even do it like that? This is a really strange way of doing it. Oh yeah, it's a size. It's size of the element. Google Chrome showed me or Snap window when started fed. What is fed? Okay. Did it recompile? I need to recompile. It complains about something. I'm not sure what it complains about. Comparing argument for incompatible pointer type. Well, it is technically true, right? But I thought that I could, you know, get away with that. I thought I could get away with that. Apparently I couldn't. And yeah, I think it's still incorrect. Because in that particular case... F'd. Oh, okay. Okay, let me actually quickly grab some water. Because I didn't bring any water before the stream because it was filtering. I hope it actually finished filtering. And then we're gonna continue. Yo, what's up? I hope it wasn't too long. Okay. Alright. So, something is really strange going on, that's for sure. How do they count the differences? Finally, device build adapter is always 3 higher than the highest adapter, so its rating is 22 joules, always a difference of 3. I thought I actually take that into account. I thought, oh shit, I don't. I actually don't take that into account, and you know why? Because I have to. Yes, I didn't increase exercise like this after I edited the last element here. That's exactly the reason why it didn't work. So I just forgot this line, and that's why it didn't count enough of those things. And there we go, 35. Cool. So the last one, this is larger. So difference, and so by the way, so the second one has to be 22.0, and our result 23.68, not even 69, unfortunately, not even 69. So I'm gonna put it there, and first try it, motherfucker. Continue to part 2. Okay, cool. Jesus fucking Christ. All right. So to completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Oh, yes. How is that? The backpack problem, right? So the backpack problem. Yeah, knapsack. It's actually not backpack. It's knapsack problem. Yeah. Fucking classic, fucking classic. The problem combination optimization given a set of items, each weight and value determine the number of each items to include a collection, so blah 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 blah. Yeah, okay. CS 101. To completely determine whether you can have enough adapters, you will need to figure out how many different ways it can be arranged. Yeah, it's probably DP. But I haven't done any DP for quite some time, so it would be actually pretty good exercise for me to remember how to do this shit. To be fair, I never actually wrote DP in production, like never in my entire life. Like, is there any commercial project where you need to write DP? I wonder. Okay, every arrangement needs to connect the charging outlet to your device. The previous rules about when adapters can be successfully connected still apply. The first example above, the one that starts with 16, 10, and 15 supports the following arrangement. Okay. The charging outlet and your device built-in adapter are shown in the parentheses. Given the adapter from the first example, the total number of arrangements that connect the charging outlet to your device is 8, the second example above. The one that starts with 28, 33 so has many arrangements. Here are the few. In total, this set of adapters can connect to the charging outlet to your device. Distinct arrangement. You glance back down at your back and try. It's not even a knapsack. I don't think it's a knapsack. So glance back, try to remember why you bought so many adapters. There must be more than 1 trillion valid ways to arrange them. Surely there must be an efficient way to count the arrangement. What's the total number of distinct ways you can arrange the adapters to connect the charging outlet to your device? So far it feels like a two-dimensional DP. The first dimension is the current adapter from left to right. The second dimension is whether we include that adapter to the chain or do not include that adapter to the chain. I think that's like literally two dimensions. The first dimension is from 0 to n, the second dimension is 0, 1. And essentially just iterate from left to right and basically check all the possible combinations. Actually, not check all the possible combinations. Yeah, something like that. All right, let's try to implement that. I wonder. Two distinct ways you can arrange adapters. By the way, so here are the few. Okay, so this is a sample, right? So this is a sample. The second example above has many arrangements. Here are the few. So the only answer I know is for this for the first sample, right? This is the only answer I know. Okay. So let's introduce DP. So DP is going to be like around this, and this is going to be the second dimension of DP. So this is part 1. And what's funny, for DP we'll also need to sort everything. So I'm going to leave this piece of code as it is. So I don't even need to refactor anything, to be fair. I think so. I'll have to only introduce part 2. Only introduce part 2. 69. Part 2, D, part 2. Okay, so what DP stands for? The amount of chains ending with this number if you don't include this into the chain, right? If you don't include this into the chain, plus the same, but if you do include that into the chain. That's pretty much what it is. So DP0 starts with that, and you always include that, right? You always include the first value. I'm not quite sure how to initialize that. I'm gonna initialize these things with zeros for now, but I'm not sure if it's gonna go really well. So the next thing we need to do is to see. We also have to go quite far back in the past to do all of that. So it's going to be less than exercise. Exercise and okay. To calculate dpi 0, we know that we're not including this element into the chain. So that is kind of strange because we're kind of always including it. Maybe we should rethink the DP. Maybe it's going to be one-dimensional one, but it always includes the current one. Yeah, it always includes the current one. Yeah, it doesn't have to be two-dimensional because two-dimensional actually makes everything difficult. Yeah. So essentially, let me draw. Let me draw over that. So we're gonna draw a little bit. Man, I forgot. It brings back so many memories. Jeez. Oh. All right. All right. So essentially, yeah, if we have this kind of chain, right, and something like this, and imagine that we're calculating dp for this one. So this is the current dp, right? So if we don't wanna and we'll always assume that we include that one. If we don't want to include this part, right, we don't want to include this part, we basically don't query dp for that one, so we just ignore it. Just ignore it, and we query dp only for this one. So essentially, to calculate dp for this one, we go as far back in the past as possible. Yes. So, and we sum up as many things as possible. So it's going to be actually all of like n squared dp, but it's going to be one-dimensional. Yeah, I think this is the way to go, and it's actually way simpler than what I was trying to pull off. Did you donate? What are you talking about? You want to donate me? So there is like a donate button down below. You can donate me. By the way, hello, Synchron. Welcome to the stream. Okay, so I'm gonna assume that here, so this is like 0, right? And there is only one way to connect this thing. There's only one way to connect this thing. And now, imagine thinking I didn't understand what you're talking about. You baited. All right. So, how are we gonna do that? It's gonna be j I minus I. I think I'm gonna also use like this while excess j minus excess I, the absolute value. We know that excess I is bigger than excess j, so we can quite safely do something like this. So right, while this thing is less or equal than 3, we do minus j. And there is another one, and j is greater or equal than 0. Something like this. Right. And essentially what we do, that's fucking too easy. This is the easiest DP I've ever encountered in my entire life. If I understood it correctly, of course. I might actually misunderstood it, but that's it? The fuck? What the fuck? And oh yeah, thank you so much, Aguduk. You are the real competitive programmer here, not me. I never fucking succeeded in this shit. But there we go. This is unfair, right? This is one of these problems that if you know how to solve it, it's super easy. If you don't know how to solve it, you're never gonna be able to fucking solve it. This is really unfair in my opinion. Like, for people who don't know how to do dynamic programming, this is impossible. This is straight up fucking impossible. This is really unfair in my opinion. And well, you know what's bad is that people quite often give this kind of problems in coding interviews. Not specifically DP, but something that requires knowing something. And usually you have to know something computer scientists spend decades coming up with, and they require you to come up with that like on the spot, which is fucking horrible. But I mean, it is what it is. The entire hiring system in software development is dumb anyway, so. Anyway, so I think that's basically the idea. You can try to do that recursively. But it went straight into the DP. I wonder, do I need to initialize this with 1 or with 0? We'll see. So, by the way, what do we expect from, for how many of these things we expect from here? Iterative DP. Yeah, you can do a recursive one with just memorization. So we expect 8 results from the sample 1, right? So this is the sample 1. I already wired part 2. Everything looks okay. And we got 8. Would you look at that? We straight up got 8. And it grows quite exponentially. So I'm gonna assume maybe recursive with memorization. We can try to do that with recursive with memorization, but let's actually give it a try. Fuck. It's not the right sense for it's too low. Oh shit, it is in fact too low, but this one actually worked correctly. Overflow? No, I don't think it's overflow, but we can try to see if it is in fact overflow. We can try to replace that with int64 or something. Hello Oblivionaire, welcome to the stream. So let's do stdint, and I'm gonna replace all of these ints with int64t, and let's see if it's gonna make any difference. So we're gonna go. Why didn't it complain about anything? I really don't like the fact that it didn't complain about anything. Int long, but I mean on 64-bit systems, on a system, I don't think they're that different, aren't they? So size of int, size of long, right? So and also exit. Right. Oh, they are fucking different. Oh, okay. But the problem is that when I'm reading things, so I think this is what I have to do now. Conversion lacks. Oh, okay. So it's doing something. Let's find all of the else. I think it has to be LD. Yeah, it has to be LD. Have you compiled it yourself, or you using the package because the package from Debian sometimes? What are you talking about? OBS, I mean. Oh, I build OBS myself, of course. Like, I mean, if you're using Debian, you don't have any other choice but compile it yourself. Seriously. Okay, so what do we have here? Expects longin but has a type. Oh yeah, and part. I'm gonna start compiling my C code with C++ compiler because holy fuck, it doesn't do shit. Okay, so here's the longs. This one has to be. Oh, wait. This has to be in. Oh my god, C. C fucking kills me. Do we have anything else? This has to be long. Compare ints. Compare longs. Was it long? Yeah, I still call it compare. Oh my god, I'm so dumb. Okay, it was overflow. All right, so it was actually quite perfect overflow because it even went over. The negative part. That's how huge it was. But I wonder if this is not overflow as well. So what if I do unsigned long? Because all of them are. All of them are positive anyway, so whatever. And query replace LD with LU. And let's see if it's gonna change anything. And this one, oh yeah, this one doesn't really have to be. I could have just used integer for that one. I don't think it actually affects. So I think this could be the final solution. So let's give it a try. And first try. Well, I mean, solution was correct, okay? So solution was correct. It's just I didn't know that it's gonna overflow, right? So technically it is a first try. I came up with the correct solution first try, but it was like specifics of the language, right? Specifics of the language. If I, for example, used Python, it would have passed like first try because the Python's ints, you know, they extend automatically. So I think we can safely say that this is the first try, right? Please, technically it's a first try. Come on. How do you solve it? It's a DP. So do you guys want me to go a little bit deeper into how you solve this kind of shit? So the first try. Well, I mean. So the first try, virtual first try. Yes, please. Okay, so to be fair, to explain how exactly I did that, I need to explain the dynamic programming, so I need to make a lecture on dynamic programming and stuff like that. But generally enoughly, for like in the future, just Google up a bunch of articles on dynamic programming, try to read them and try to understand them. They're hard. Understanding dynamic programming is as hard as understanding recursion for the first time. Right, but once you get it, it's relatively easy unless you participate in ICM, ICPC or code forces, because they usually tend to take dynamic programming quite far to the point that they may have like, you know, 5 dimensions of dynamic programming or something. By the way, I heard the horror stories of somebody solving some problem with like up to 17 dimensions of dynamic programming or something. Knapsack is also a pretty good example of that. Yeah, 17, but it wasn't like that huge of a complexity because the first dimension was big, but the consecutive dimensions were very small, like 1, 2, 3 or something like that, and it was totally unnecessary, by the way, for the solution. It's just the author decided to go that way. All right. Yeah, something like that. It's DP23223, whatever. Anyways, so okay, I think I want to commit this thing first before I go into explaining how you even solve things like that. So I'm gonna do readme md. So, but don't get discouraged, Nafli, seriously. As I already said, it's a very unfair problem, right? Because it's very easy if you know the trick. So you have to know the trick. The thing is, I didn't come up with that trick myself. I didn't invent dynamic programming myself. I'm pretty sure majority of people didn't. So they just learned it in uni or by themselves or, you know, stuff like that. Nobody invented that shit except the inventors of dynamic programming. So, and again, so if you knew this trick, you would solve it as easily as I did. If you don't know the trick, well, it's pretty much impossible. So you have to know it. So don't get discouraged. You just didn't know the trick. Don't think of yourself as stupid or anything like that. So keep that in mind. It's very important. All right. So I'm gonna day 10. Plus, you're too young. You're gonna learn that in uni anyway, because they usually teach you that in uni. So don't worry about it. It's not that big of a deal. In C. Quick start. Install. I think I'm gonna go with the same explanation as C++, because we already mentioned these things there. Install Clang or GCC, and make sure GCC or Clang are available in the path, and just do that. But instead of G++, you're going to do GCC. Instead of that one, you're going to be using Clang. But I never actually, yeah, like, I have no idea what is going on with my fonts when I edit this kind of thing. All right, so cool. So I also need to ignore some of this stuff. So I need to ignore this stuff. Don't I have any garbage? I don't have any garbage. It's gonna be 10. So implement add day 10 solution, and let's push that right into the repo. These solutions are available right here. So in AOC 2020. There we go. Okay, let's take a look at what we have in here. All right, so this is the dynamic programming. Okay, so hello, the Voodoo Puppet. I would really like ask you to speak English, because this is primarily English speaking stream, right? And it's too much for me to too much work for me to translate everyone's Russian message. I'm really sorry. It's only 10 lines. Yes, it is only 10 lines. Okay, so let's try to solve that without DP, right? Let's try to solve that without DP. How would you solve that? So you can solve that recursively. Let's introduce a function that answers the questions, like count combinations, right? Count combinations. You're trying to solve it recursively, right? Okay, so count combinations for int I, right? What this function means. So you have a sequence, where's the 0, 1? So let's actually take this sequence, let's actually sort it. Can I, wait a second, can I sort it like in, like proper? God fucking damn it, mate. All right. Okay, I think I have a way to do that. So I can do sort n, sample 0, 1. I just want to like sort some numbers. Why is that so difficult in 2020? All right. So imagine that you have this sequence, right? It's already sorted. And somewhere here we have 22. So this one is the plug, this one is the device. All right. So what count combinations for tells you? So these things are numbered from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I is supposed to be the index. So it accepts the index of one of these things. All right. So when you say count combination for example 6, this function is supposed to tell you how many combinations of plugs that end at here. Right, so that's what it answers you. How many combinations of plugs that end specifically here. Right, and your actual answer, the answer that you want to print for the advent of code, is going to be 12. How many combinations that end specifically here. So that's what you want. Cool. We established that. Now, how can you implement such function? Well, like here is the count combinations for 2020 for 12. Right, this is what we're trying to compute. No. So you look back and you see with which you can connect. Can I connect with 11? 12 minus 11 is 1. So the answer is yes. So the return is going to be count combination index minus 1. Okay, I can connect with that. All right. So what if I skip 11? What if I want a combination that doesn't include 11? Can I connect with 10? 12 minus 10 is 2. Okay, I can connect with that. Right, I can connect with that. Can I connect with 9? Actually, we should look at the numbers. Oh my god, I'm sorry. We should look at the numbers. Not the indices, but the numbers. I was looking at the right thing. So we connect. You can connect with that, but you cannot connect with that. Right. So the idea is, for the current index, you go back as much as possible and you try to include all of the combinations that you can connect with. So look, for J, index minus 1, for index minus 1, and if the current index minus J is greater or equal to 3, that means you want to include it in the final result. You want to include that in the final result. This one has to be J. And what you do here, you do result plus count J. So you see, you basically, for the current index, you're going back and recursively count all of them until you cannot count them anymore. And of course, you have to check that you reached the end. But you also don't have the base case, right? You don't have the base case. So, for example, if index is 0, there's only one combination that you can return here. And here you go. Here's your recursive solution. Seriously. So, yeah, it's going to be minus J. Does it make sense? Does it make sense? This is not dynamic programming. This is just a recursive solution. And then for the part 2, you want to just return count combinations for 12. So yeah, you start with that, and then you assume, can I connect with 12? Okay, I'm going to count combinations up until that one. Then can I connect with 16? If I can, I count combination up for that one, and so on and so forth. Like, I'm trying to go back as much as possible, and this is the recursive solution, which is basically brute forces all of the possible combinations. This is not the recursive solution I had in mind at all, but I was probably just being Pepega. Well, you never encountered these kind of problems before, so you don't have experience in solving them. Does this solution make sense? Does it make sense? Look at it carefully, and do you have any questions? It makes a lot of more sense for sure. But I'm gonna tell you what, this solution is hella slow. So let's actually take a look. So this is gonna be unsigned signed int. Maybe that one has to be integer. So let's try to incorporate that into our application and see how it goes. So this is going to be part 2, and we're also going to have part 2 slow. Assign look, part 2 slow, right? And what it will return, it's essentially going to return count combinations for excess size -1. So because we're calculating for the last element, so this is the entire solution. And let's incorporate that in here. So part 2, slow. Return in, yeah, thank you. But I'm pretty sure the compiler will tell me that, so thank you anyway. Okay, so part 3. God damn, and C didn't even fail with the compilation error, it just said that I'm using something that may be resolved by a linker later. And as you can see, it still calculates the slow. It still calculates the slow. Even though it is a correct solution, it's still calculating it. It's still calculating it. That's why it's not gonna actually, well, I mean, you can try to implement that solution as just wait, like leave it overnight, but I'm not even sure how much exactly time it will take. I think the solution in that case is gonna be exponential, right? And it's really not gonna fly. It's really not gonna fly. So let's try to understand why exactly it is slow, right? Why exactly it is slow. So let's actually try to print the indices for which we compute in this function. So remember that we have a limited amount of indices. In fact, we only have indices from 0 to 100, to actually to 99. Right, we only have 100 elements. So there's only 100 possible values for that function. There's only, yeah, it has to be less than 3. Yeah, it has to be less than 3, but it's gonna be slow anyway. So, and look, if we try to run this thing, you will quite easily notice that it keeps recalculating the values for the same indices over and over again. It keeps recalculating indices for like values for the same indices over and over again. So you can use memorization. Yeah, really, you can use memorization, and that would be actually a reasonable solution that you can apply. But there is even better solution that will let you get rid of the recursion completely, right? So you have only 100 indices, and each index depends on the values of the previous ones. It never depends in the future, it only depends on the past. What if for each index you create an array of n, and you basically will iterate them from 0, right? 0 is going to be 1, and you basically apply the same thing, but, you know, just referring back to the elements of the array. You see what I'm doing here? So it's the same thing, but like linear. So basically we just get rid of the recursion whatsoever, and we work directly with the memorization table, right? So you can use memorization. So for now it's going to be an okay solution. But the dynamic programming is going to be basically memorization table, but you fill it up without the recursion. That's kind of the point of the dynamic programming. So you come up with the memorization table, and then at some point you get rid of the recursion and just fill up memorization table yourself iteratively, because it's going to be filled up in a particular pattern anyway. All right. So I'm not sure if this explanation makes sense, but I tried to explain it as best as I could. So there you go. Not really DP can either recursive or iterative. Well, yeah, for this particular case, yes, it could be also recursive, yes. So sometimes it's kind of difficult to get rid of recursion, yes. All right, so yeah, you're welcome. So it's kind of difficult to explain dynamic programming. You kind of have to do it several times to get the gist of it, right? It's just understanding it is like understanding recursion. Like to understand recursion, you need to understand recursion. This is kind of like a similar situation. All right, so okay, I guess we solved that, and I think I already pushed everything, didn't I? Yeah, I already pushed everything. Okay, this thing is going to be available in here. So the entire source code is available here, so feel free to use it if you want to, of course. Do I want to solve the day 11? Do I want to solve the day 11? But the problem with the day 11 is that, like, I have to come up with another language because I wasted C. So yeah, it would make sense to try to solve day 11 because yeah, I'm really lagging behind. So what language can we use? We already wasted so many languages. Do you guys have any suggestions? Maybe I don't want to use JVM languages, I'm sorry. We already used Haskell, we already used Python. Nim, okay, I think we're gonna use Nim. Alright, cool. We already did Haskell, Jesus Christ. Look, I specifically opened the list of languages, so you... God damn it. Alright, 11 is gonna be Nim. I'm not gonna look into the solution, right, so I'm gonna just prepare the border plate first. Nim it is. I forgot how to program a Nim. Do I even have a Nim compiler here? Oh shit, I do. Epic. Absolutely fucking epic. Alright, so I think I need to update. I already chose the language, people. You can stop suggesting. Alright, you are all too slow. Day 11 in Nim. Oh shit. Day 11 in Nim. Update CMD. Oh, fuck. Okay, I forgot to. Project. It's really hard. Advent of code 11 in Nim. And that's gonna be the last advent of code that we're gonna do for today. Okay. I forgot how to program in Nim though, so I wrote one application in Nim, but I forgot how exactly you do entry point. How do you do entry point? Let's find out. So I remember like entry point is kind of similar to Python. You just check that this is the main module or something. Oh Jesus Christ, that's a lot of shit. Okay, it's a proc main, and oh, you just call main. Okay, whatever. So that's gonna be the thing here. Boomer. Well, yeah, you can find the source code here if you're interested. You're probably new here. Okay, so proc reach. Okay, so this is equals. And do I do pass? How do I indicate? How do I indicate? I discard. Yeah. Discard, and then I call main. There we go. Okay, so and I need to iterate over command line arguments. Nim command line arguments. So this is the problem. How to get access to command parse opt and what else? So I remember there was like standard library or something. I don't really need parse opt. What I really need is just a list of command line arguments. Okay, so if I go to docs, is Nim interpreted? No, it's compiled. Args? Is there something like args? Nim is compiled, yes. Well, I mean, it's translated to C and then compiled. You can also translate it to JavaScript if you want. Oh boy. Command line arguments. Wait a second, I did that in Boomer, so I can actually steal that from Boomer. So proc main. Param count. Okay, so it's something like param count. Param count. Is it defined? Oh, I think it's just, yeah, I think it's just param count. Okay. So do we have any for loops here? Nim for loops. Yeah, I haven't programmed the Nim for quite some time already, sorry. For I in a range, in a particular range, but which range? It's a custom range. So custom range. I just want to. I think it's done something like this: 0 param count. Yeah, it's something like this: 0 param count, and then param count. I can do param string, and if I understand correctly, I can do echo param str I. Okay, I think I'm ready. I'm almost ready to do all this stuff. So this is going to be makefile, and I need to compile this entire thing. So I do not remember how to compile, so I'm going to just try to do something like this and see if it's going to work or not. And it didn't work, definitely. Used config invalid command. Okay, so I think what you do is you do something like C indicated that you want to translate it to C, and it kind of worked. Param count. And param count is unavailable. So I think I need to import something. I think I need to import OS. Import OS. There we go. So if I do something like this, the compilation time is amazing, by the way, and it worked. So now if I do something like test, which depends on main and a bunch of inputs, right? Inputs are equal to sample txt for now at least. Let's actually create sample txt. Let's actually create sample txt, and this one is going to be phony, right? So, and what we're going to do here, I'm going to just do main inputs. There we go. And let's just try to run it. It's going to recompile everything, of course, and it managed to do that. Okay, I think I'm actually doing that. So let's introduce procedure called solve file, and this is going to be file path. I hope string works, and this is where we're going to do this kind of thing. Echo input file, and will something like that work? I don't quite remember if it will work or not. Does anyone know? I think it won't. Yeah, I think it, well, I mean, has to be solve file, param stri, and let me see if it's gonna work. Compilation times kill me. Oof, 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 oof. Okay, and we also need to skip the first argument because it's the name of the program. We don't want to handle that, that's for sure. Look at these compilation times. Look at them. str1 and str2. I mean, it already works. You see, it produced the result. It produced it already, so. And that's exactly what I said here, so maybe that's okay. Maybe, I don't know. Okay, so I think the boilerplate is ready, and we are ready to read the description of the problem. This is not what I wanted. What did I press? Oh my god, please, where are you going? Okay, so 11th problem. You just came in, you look much better, it suits you a lot. Thank you, SK01001011. Thank you so much. Alright, so let's take a look at the 11th problem. Seating system. Cheers. The fuck is this? Oh, I know, these are chairs, because they're else. Why did you add a phony to the makefile? Google up phony targets and make files. You're playing lanes with plenty of time to spare. The final leg of your journey is ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you... what is ferry, by the way? You realize you're early and nobody else has even arrived yet. Squad seating system, yeah. By modeling the process people use to choose or abandon their seat in the waiting area, you're pretty sure you can predict the best place to sit. You make a quick map of the seat layout, your puzzle input. So that means Yeah, so this is gonna be the sample, by the way. I'm gonna straight up just put this thing here. Yeah. Boom. Oh, okay, thank you so much. Did you use Google Translate or something, or did you know that? Okay, so you make a quick map of seats. Yes, okay, I see. Thank you. Okay. The seat layout fits neatly on a grid. Each position is either floor, an empty seat L, or occupied seat, the hash thingy. For example, the initial seat layout may look like this. Okay. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. One of the 8 positions immediately up, down, left, right, or diagonal from the seat. The following rules are applied to every seat simultaneously. If seat is empty and there are no occupied seats adjacent to it, the seat becomes... What the fuck is this game? This is the most scuffed game of life I've ever seen in my entire life. This is so overstretched. Oh my god. Oh, Jesus. Okay. If the seat is empty and there is no occupied seats adjacent to it, the seat becomes occupied, like all of a sudden it appears. If the seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Otherwise, the seat's state does not change. The floor never changes, seats don't move, and nobody sits on the floor. Okay. After one round of these rules, every seat in the example layout becomes occupied. After a second round, the seats with 4 or more occupied adjacent seats will become empty again. This process continues to the 3 more rounds. At this point, something interesting happens. The chaos stabilizes, and further application of these rules causes no seats to change state. Once people stop moving around, you count 37 occupied seats. Simulate your sitting area by applying the seating rules repeatedly until no seats change state. How many seats end up occupied? Oh shit. Okay. I can easily solve that in C. I will need to think how to solve that shit in Nim. That's the real challenge, by the way. Nim is the real challenge. Okay, so maybe we can have like an array of strings, and this is where we can keep all that. Alright. So I'll have to think about that. To the array time, yeah, probably, but here's the thing. I will have to read that from file, and what's going to be the easiest way to keep that in file? We'll see. So Nim arrays. How do you do arrays in Nim? Nim is literally the challenge here. Okay, so you have array from something to something. Okay, so maybe we can do let some sort of input. Okay, for the solve file, I'm gonna just test some oh shit, we should have actually used Pascal. God damn. Okay, 69. Nice, very fucking nice. So for the array, you have indices, right? So you have like how many of these things we have? 10 lines. Cool. Do we already have 10 lines? I think we do. There we go. We have 10, and the strings and the elements are going to be strings. There we go. And after that, I should be able to do this kind of thing. Okay, so I just wanna, hard code this thing for now, and then I'm going to change that. There we go. So here's the input, and is it even possible to just, you know, print the, like arbitrary types and see if they're gonna work or not? Maybe. Oh, you can just basically print arbitrary types. That's actually super nice. Okay, what about dynamic arrays? Dynamic array. How do you do that in Emacs? What a nice question. Thank you for asking that. I do that with my hands. I have no idea what you're trying to ask me, seriously. Multi-line editing. Well, you can Google up Emacs multi-line editing. All right. So dynamic arrays. Dynamic arrays. So you can have sequences. Oh shit, that's cool. So a reference to a sequence of strings that is initialized with. Oh, that's very nice. That's very nice. Well, yeah, specifically I'm using rectangular selections. You can Google up Emacs rectangular selection. And that's exactly what I use right now, but I also have extension for multiple cursors. So I use combination of that plus rectangular selection. Yeah, so I think for this kind of stuff, we're gonna use sequences. Can I just do something like this, like sequence, right? And then try to print it. Hopefully that will compile. Oh shit, it didn't compile. But oh yeah, for a sequence, I have to do it like that. It works, and what's cool is that at any point I can add your mom, and that will work, I think. No, your mom didn't work, unfortunately. Okay, expected one. Is that because... I think this is because it's immutable, so I have to replace let with var, and I think that will work. I think that will work. Yeah, your mom work. Your mom has to be immutable to actually be pushed into the sequence. Okay, so that makes sense. Cool. And this is perfect. So this is going to be our board, right? This is going to be our board. And what we're going to effectively do is simulate the next step. Simulate the next step. Oh boy. Oh boy, oh boy. So we'll have to make a copy of this thing at some point. Right, we'll have to make a copy. Okay. So proc next round, right? And we accept the board. I don't remember how to pass it by a reference. Nim pass by a reference. So I want to try to pass that by a reference. How do one pass by a reference? So you can do something like var, right? And that will ensure that inside of the next round, we will be able to mutate the board. We'll be able to mutate the board. Or maybe we can actually return the next board. Why not? It will depend on the input. Maybe the input is going to be insanely huge, right? So let's actually try to find out. So get your puzzle input. Doesn't look that bad, to be fair. It's actually pretty small. Just like my peepee. Okay. Alright. Cool. So maybe we can return a new thing here. Yeah. So, and then we can iterate until they don't... Cool. So let's imagine that we have this. Let's imagine that we have this. And so this is the initial thing. This is the initial input. And we're going to try to have a next input. So this is going to be next input. Yeah, we could make it like let. input 1, next round for the input, and while input 1 is not equal input, I think this is not how we do that. I think I have some weird reflexes. So we do input equal input 1, and then for input 1 equal next round input. There we go. So you see? And we basically keep simulating until we're done simulating, and after that we can try to print input. Right, actually echo input. There we go. All right, and now we need to just do this kind of simulation. I have no idea how to do that. So I need to copy the board. Yeah, I need to copy the sequence. Nim copy sequence. Is it even possible to copy the sequence? So there's a sequence utils. Is that a thing I can do? Copy. That's pretty strange. System run copy of sequences. Is it even possible to copy a sequence? I actually wonder, chat. Is that a thing you can do? Is that a thing you can do? So let me try to run this entire step. Just do result board. You think it's gonna work? Hello Old9, welcome to the stream. So, what are we doing? What I want to try? I want to create a bunch of sequences. So this is going to be the first one. 1, 2, 3, 4, and then we're going to have the second one axis. But then I'm going to push 5 into the axis, and then I'm going to print axis, and then I'm going to print y's. So that's what I want to do. And let me try to see what's going to happen. So you cannot push because all of that. Yeah, it's add actually. It's actually add. It didn't work. So, at all, which is kind of strange, like it didn't even copy anything. Is there like a keyword copy? Wait a second, there is a keyword copy. Can I apply it like this? Will it do the copy? Will it do the copy? It doesn't even know that, but Emacs highlights it anyway. Okay. System does create a new sequence copy. Cool. The short one is mostly yeah, mostly. The long answer is that the sequence assignment is handled by the procs appearing in an assign module, which is part of the system. You can try search for ty sequence. Okay, so I think whatever. I'm gonna create just an empty sequence here, right? So that's what I'm gonna do. All right. So we're gonna have some sort of a result, and I think it already has a result variable, nim result variable. So like coming up with a solution in nim is already a challenge by itself. So we have a result variable. Yeah, and result variable is actually equal to this result. And I suppose initially it's 0, and that's exactly what we're gonna do. Okay, for row in board, for row in board, what I'm gonna try to do here, I'm gonna try to push that board into the row. And another interesting thing, if I push a string and try to modify it, does it create a copy? Does it create a copy? All right. So if I have something like var access, like I'm really not sure about the semantics of this language, seriously. So this one is going to be sequence of string hello Panapudi, welcome to the stream, something like this. And then if I do something like push push access 0, right, push access 0, and then I try to modify this single thing. I wonder if I can do something like b. Is it even possible? And then I'm gonna try to do echo and wise, right? And let's try to run this entire thing and see if it's gonna produce something. I keep calling it push because it's supposed to be add. Okay, so there's another place where I did push. Discard. Okay, it worked. So it actually made a copy of the string. This is exactly what I wanted, and it's almost impossible to Google these kind of things, right? So because Nim is such an unpopular language, the Google won't tell you shit. So you literally have to check the semantics like that, like will something like that even work or not? So there we go. So if I push a row, it will create the copy of that row, which is pretty much exactly what I want. So that's cool. So, and the next thing we do, we're iterating. By the way, does it work exactly like Game of Life? So we'll have to calculate that on the next row. Yes, but if you use it often, it's an okay language, I guess. Probably, but who uses it often? I don't really know. Okay, so can I also have the size? Maybe that's what I need to do. So I'm gonna have I from 0 up until the length of this thing. Right, so, and then I can do something like board I. I'm gonna add it to the result. Then I want to iterate j in 0, board I, length, and this is where we're gonna do all of this stuff. Okay. So we have to do 0 board len -1. Yeah, probably. Thank you. So now I need to count neighbors, right? So if seat is empty, then if occupied, 4 or more seats adjacent to the... Okay, so let's introduce count neighbors. Hello, Dandy MacG, thank you so much. Count neighbors. So call them like that. So we're gonna accept this thing, like this, and it will return us an integer counting the neighbors. Okay. And let's follow the rules. I think we're finally ready to follow the rules. What we need to check here is whether... Yeah. So what is the switch case in Nim? Switch case. I don't quite remember. Case statements. So case board ij, right? Board ij of, if this thing is empty, we do one thing, discard it. If it is occupied, we do another thing. And there's also last thing here, else we do nothing. Right. So what we do? If seat is empty and there's no occupied seats adjacent to it, the seat becomes occupied. Okay, and let's count neighbors as well. Count neighbors and provide the board. And if neighbors is equal 0, then result ij becomes this. And we know, so if it is something else, if it is occupied, okay, if we have some neighbors there, that means it's gonna stay L according to the rules. Okay, so if seat occupied, and 4 or more seats adjacent to it also occupied, the seat becomes empty. Okay, n bars greater or equal than 4, it becomes empty. And I guess that's it. I guess that's the floor will never be changed, and yeah, everything should be okay. Everything should be okay. So now we need to count neighbors. Count neighbors is just like the diagonals and stuff like that. Okay, and we also have to take into account the situation of like going overflow. So we don't wrap around, right? We definitely do not wrap around because I don't remember them saying anything about wrapping around. So that means we have to be a little bit more careful. So do I do my usual like iterating 3x3 square? I could try to do that. We could try to iterate them. So for di in, how can I have a range? Nim ranges. How can I have a range? Well, I mean, I can just do -1 to 1, and it includes the last thing here. Okay, so that's actually perfect. For dj in -1, 1, right? And if not di equals 0 and dj equals 0, and we actually apply the De Morgan's law, it's going to be like this. Then we can try to do something here. And oh, and by the way, count neighbors, we'll have to provide the positions. I0, J0 is going to be integer. So I is going to be I0 plus di. So then this is going to be dj, and there we go. And if are you going to do site time workout? Yes, of course. So now we need to check whether it's within the acceptable range here, right? So that's what we need to do. We need to know width and height. So width is going to be board length, and height is going to be the actually this is the height, right? And width is 0, length 1. Okay, now I remember that in Nim you can quite easily do something like this. This is a row. That means we can just do it like this. I think I remember it. Yeah. But I'm not sure if I can do. Well, I can chain them together. J is gonna be. You know what? I want to rename like I0 and J0 to row and stuff like that, because I think it's going to be more readable. So it's going to be row 0. This one is going to be column 0. Di is actually d row. This one is going to be d column. D column. I is going to be row. row, and j is going to be column. Okay, so, and once all of these things are true, right, we count neighbors. If board row column column equal to occupied seat, we increment the result. There we go. That should be it, actually, believe it or not. So count neighbors, this is how we count neighbors. Then this is how we simulate the cellular automaton. And I gotta say, the arithmetic result variable is extremely useful here because you don't really have to think about it, you just fill it up. Overall, like, the resulting code looks better than I expected. Yeah, it looks way better than I expected. This is really strange. Okay, let's try to compile it. I'm gonna try to compile the executable, and we'll see how it's gonna go. And it doesn't compile. Nice. I really like that. I really like how my beautiful code doesn't compile at all. So attempted to call this. Is it because it has to be or? Probably. Oh, okay. So instead of like, okay, you literally have to do it like that. Nice. Okay. So another one. So 11. Got. Okay. So I think it doesn't really work like that. So you literally have to split them. For some reason, I thought that maybe Nim supports this kind of like a range check, but it probably doesn't. So, but it's relatively easy to check. Just do it like that. But Zozin, you don't need parentheses there. Zozin, why you put parentheses there? Okay, so yeah, you also have to provide the rows and columns. So I'm gonna call it row. This is gonna be column. Okay, this is gonna be like this. Row. This one is gonna be column. Yes, please. Just thank you very much. So row column, cool. Is it gonna compile it now? Invalid indentation 54. Okay. Okay, that makes sense. So we're gonna put discard here. Does it compile now? Oh shit, it does compile. So we have some unused imports and shit, but that's totally fine. That's totally fine. What I want to do now, maybe I want to just iterate through several rounds and see how it's gonna go. I just don't want it to stack in like infinite loop and don't tell me anything. That would be quite bad. Alright, so we're gonna just print input. It's actually echo input, and then I'm gonna also separate it with the lines so we can see separate generations. And let's see if it's gonna, you know, stop at some point, if it's ever gonna stop. Nice, it never printed anything. It never did anything. Cool. I'm really happy about that. So that means the next round didn't do anything at all. Alright, so let's actually print the input, right? And also print the second, the result of the next round, and see what's gonna happen. Oh, I'm an idiot. Oh, shit. Yeah. I'm only compiling this thing, but I'm not running it. I really apologize for that, for being such an idiot. Yeah, this is what I need to do. Okay, nice. What happened? Input sample. Unhanded exception, index 10, not in 09. Why? And where did that happen? Count neighbors. Count neighbors. Yeah, okay, so yeah. That's true. That's actually true. There we go. Alright, so is it gonna work now? Oh shit. Well, I mean, at least it stopped, okay? At least it stopped, which is already fucking great. Which is already fucking great, and I'm super happy that it stopped. So now, let me try to do something like this, right? And Boom. And let's compare that with whatever they have at the end here. So this process continues 3 more rounds. At this point, something interesting happens. They stop, and this is the stop, like a final state that they have here. Is it the same? I think it is. I mean, we can even do something like this. I can just remove this bullshit, and then I can try to remove this bullshit, and just take this thing, and yeah, they're the same. Emacs says that they're the same. Cool. So we successfully simulated this entire stuff. It was a little bit painful because I kind of like I'm a little bit rusty on using Nim, but I really like how these solutions turned out. They turned out really like, yeah, so pretty good. All right. So afterwards, we just print the final solution, and what we need to do now, we need to count how many seats end up occupied. Okay, so we just need to iterate through all of this stuff and count how many of them are occupied. Pretty straightforward, not gonna lie. So I wonder if I can do something like this: rows in board, and then characters seat in row, and then if seat is equal to, actually this thing could be a result. Right? This thing could be a result. If seat is occupied, just do result plus 1. And yeah, this is how it has to be. And this should be, in my opinion, part 1. Yeah, this should be part 1. Then we can have something like proc solve file. So it's going to be file path string, and it will return integer, and it's going to be echo input file. Okay, let me put it this way. So input file part 1 file path. Is it gonna work? Is it gonna work? Undeclared identifier board. And where that happened in 49. It has to be input. That's right, I do agree with that. I do agree with that. Solve expression is of type int and has not been discarded. Excuse me? 60? Oh, I see. Yeah. That's true. That's actually pretty cool. So it forces you to discard or whatever. I mean, a lot of languages have this kind of feature, so it doesn't matter. 37, right? And we ended up with 37. Okay, so we have a correct algorithm. We have a correct algorithm, but we have no way to read from file. So I have no idea how to read from file. So let me think. So, and by the way, here we can essentially accept the board instead of anything else. So this has to be yeah, and instead of that I'm gonna just basically pass the input. Yep, syntax param var, not var parameter t. Okay, but that's not necessarily what I want, because I don't want to mutate it. I want to have a copy of it. So it's called board, but can I do something like var input board? Okay, 37. 37. Okay, so now we need to learn how to read a file. Nim read file line by line, because I do remember that it was possible line by line. Yeah. That's not very good. I think I'm gonna go take a look at the boomer and steal some solution from there. Config. I think it was somewhere in the screenshot. There was like a pretty cool way of doing all of that. Yeah, you open a file. It's for writing, not for reading. Yeah, so lines. Read lines. Okay, so there was a way to read lines. You provide a file path and you get a sequence of... Okay, that's pretty goddamn cool. So the question is, can I do the following trick? Where I just do read lines, file path, and it just gives me the sequence. Give me that. Give me that shite. Okay, it didn't read all of the lines, but maybe I'm doing that incorrectly. Yeah, we'll probably have to iterate through it. So, for line in read lines, and I'm gonna do echo line. And if I try to do something like this, it didn't work, it stopped. And for the sample, yeah, that's lame. So we can have iterators. For line in file name, oh shit, is it really what I can do? File path lines? Seriously, is that what I can do? Oh shit! You can literally take a string, it has like a method, lines, and you can iterate them. And then we can do something like board, which is an empty thingy here. And then I can just do board, add line, and there we go. And here is the board. Look at that. Isn't that epic? So, yeah. It's pretty cool, and it's pretty straightforward as well. And cannot infer type of a sequence. Oh yeah, I can actually specify it can be string, sure. That's okay. Undeclared identifier input. Yeah, this one has to be word. Okay, cool. So, nice. So now we are probably ready to include the actual input here. So I wanna redownload the input. By the way, does it include the last line? I think it didn't include the last line. Okay, let me print this entire stuff. Well, I mean, it worked correctly. In a sample, we do have next line, and it returns 37, which is exactly what I want. Right, it returns 37, so everything's okay, and it didn't crash. All right, let me remove input just in case, and I'm gonna get the another puzzle input. I'm gonna copy paste this entire stuff, copy paste it here, just in case, and I'm gonna include the input into the whole thing. Right. And let's just run it and see if it's gonna work. Okay, 2093. So that's probably the thing. So let's try to put that into the solution hole. Right here, the answer hole. And bam! Fucking got cooler. How about that? First try that, motherflipper. Isn't that cool? I think it's pretty goddamn fucking cool, mate. Okay, but this is only the part 1, right? This is only the part 1. So what about the part 2? Continue to part 2. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats. They care about the first seat they can see. In each of these 8 directions, Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of these 8 directions. For example, the empty seat below would see 8 occupied seats. Okay, the leftmost seat below would see 1 empty seat, but now... Okay, I see. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty, rather than 4 or more. The other rules still apply. The empty seats that... Okay, I see. It's why I didn't change the floor, didn't change. Given the same starting layout as above, these new rules cause the seating area to shift around as the follows. Right. Again, at this point, people stop shifting around, and they have 26. This is way easier than the previous problem, to be fair. This is way easier than the previous problem, but okay. I want to slightly refactor this entire thing. I think I'm gonna make I'm gonna extract this entire solution maybe into like solve the board, and it's gonna be parameterized by this parameter and the count neighbor function. So specifically, this is going to be count neighbors version 1, right? So we might as well go ahead and query replace this to version 1, something like this. And we'll have to implement count neighbors version 2. Count neighbors version 2, and it essentially takes the same arguments. This one is going to be discard. Cool. So this is the next round. Let's introduce solve board. It accepts the board and it's going to accept tolerance, right? And the tolerance is essentially this value, right? How many people can they tolerate? And we also want to accept the function, like this particular function. What is the functional type? Nim functional type. I'm pretty sure it's not going to tell me anything. But we can try to Google something like map, because I'm pretty sure map will accept other function, and we can see how they are usually declared. So that's what I want to see. Something like map, open array. Yeah, they're usually declared like that, I see. Which is kind of strange, but I guess, okay, so why does it have to be a closure? Okay, so can I just do it like this? Count neighbors, right, so this is what we expect here, and I think I'm gonna straight up take this thing. Count neighbors, and I'm gonna select it like that. I'm not sure if I need a closure here, but this one has to be proc. Yeah. All right. So this is that. This is count neighbors. So we're solving a single board. And right, we're moving all of this stuff there. So what I'm thinking, maybe for count boards, we need to have a separate type. How about that? Like type neighbors counter is going to be something like this. I wonder if it's going to work. That would be actually pretty cool, because now I can do neighbors counter like this. It's still too long. Let's actually put it like that. And I'm gonna accept this thing like this. And for the part one is essentially result equal solve board, same board as usual, with the tolerance 4 and the count neighbors version 1. So this is the part 1. The part 2 is going to be the same, but with tolerance 5 and count neighbors version 2. So you see, this solution becomes parameterizable, and it's pretty much the same dynamic, right? It's pretty much the same dynamic. So, and here, next round, I think round should definitely accept the tolerance and the count neighbors counter. Neighbors counter, and this one has to be integer, and like this. This one is just that, and the tolerance has to be here. There we go. And in the next round, tolerance count neighbors. Cool. I think that's it. Almost. And the part 2 is this. So in this setup, the only thing we need to implement from scratch is count neighbors version 2. Right, because everything else is just the same. We're using the same code anyway. So let me try to build this entire thing and see how miserably it fails. It doesn't fail. Okay, let me try to break it because I don't believe it, because I'm a Nim compiler. Okay, so I actually made it compile first try. I suppose I'm getting used to this language. Alright, so compiled first try. Nice. Count neighbors version 2. So it's like count neighbors version 1, right? Except you just have to go in 8 different directions. You just have to go in 8 different directions and take the first one that is occupied. All right, so let's do this, shall we? I think it's gonna be pretty much like similar, because here's the direction. So at this point we found the direction, and we can organize the loop that follows that direction until we hit something or go overflow or something. So that means I'm gonna just repeat that solution here. So here is the height. This is not let. Then board 0 length. And maybe that specific, yeah, that specific thing should be somewhere here. Okay. This has to be row 0, column, it has to be inside though, column 0, while, and here's the interesting thing, while this thing, while we're there, what we're essentially doing, we might as well actually add the row or the column here, if board row column equal that, result plus equal. This is really fucking strange if you think about that. Well, and we also need to get, like, yeah, I do agree with that. I'm gonna show you what's interesting about this particular code. Oh shit. This is so fucking cool. It's the same code. I'm gonna show you some. This is so amazing. I'm not sure if you can see that, but let me show you. So, temporary one. So I'm gonna take this function and copy paste it to a temporary buffer. Maybe it would make sense to actually put them in the file. So version 1, Nim. So here's the first implementation, and then I'm gonna have version 2, Nim. This is the second one. And then I'm gonna do diff between version 1 and version 2. And I'm gonna redirect that to diff patch, or maybe patch diff, right? And that's the whole difference between these functions. So the first version looks at neighbors, immediate neighbors, but the second version actually looks far away, as far as possible. And that's the whole difference. So if became while, and let became variables, and then you break when you first find. This is so interesting, isn't it? Like, I always had this interesting feeling that if is essentially while that performs a single iteration. Right? If you think about it, if is simply without else, because with else it's slightly different, but essentially if is while that performs only single iteration. So if you want to perform multiple iterations of the same thing, you kind of replace if with while. And that's very cool, actually. Okay. I always realized that, by the way. It's just I finally saw that in action. So they can see in each of the 8 directions. Okay. In each of the 8 directions. I have colleagues who use while loops with a single iteration just so they can break out easily. I hate it. Why do you hate it? Why are you such a hateful person? Please no hateful. Not hate, no hate. Sorry. Okay, so let's take a look at what we have here. Let's try to run this. This is not what I wanted to run. I just wanted to run make. So what do we have here? So, oh shit. Sodium brain broke. Okay, so the part 2 didn't really work well, unfortunately. The part 1 worked, but part 2 kind of stuck, and I wonder why. I have a strange feeling, maybe because the board is actually... Yeah, I think maybe board is modified somehow. When I pass the board, does it make a copy of it? Or something. For example, if I don't do part 1, will it do it? Will it actually do that? Nah, it's not gonna do that, so that was not the problem here. Okay. So maybe that's... Ah, shit. Okay. Alright, while this thing... Oh, I know. So, because after that, I have to do a D-roll. Yeah, okay, it's like... I need additional code here. Okay, it's not as pretty as I wanted it to be, but it's pretty close, okay. Still doesn't work. Nice. Oh, because column. Okay. That worked. That actually worked. So, cool. Hello, Chill Touch. Welcome to the stream. This is really weird. Like, why is it so small? Why is it so small? Well... We can try that. Well, at least it is incorrect, by the way. It is incorrect. Once it occurs, the count 26 occupied seats. So, yep, it doesn't work correctly. Too small answer. Yeah. Solve board. So the tolerance has to be 5 and greater, right? 5 or more visible occupied seats. Solve board. Tolerance, count neighbors. Okay, so we keep passing the tolerance and stuff like that. So it's all boils down to just the next round then. So if it's empty, if it's tolerance, integer overflow, I don't think so. I don't think it's an integer overflow. The board is too small for an integer overflow. Okay. I finally figured out how to make a C warm to digital gloss. Okay. Oh, my mood will be tired already. God damn. So let me try to print the final result as well. If I could, of course. So we saw in the board. And then, so this is the think, and let's just try to input. Let's see. Oh shit. Okay. That's not too many, but for the second one, where we have 15, right? So this is the final result that we've got. So this is the final result that we've got, and let me see if it's more or less correct. so this is what we've got. So, and the expected state is completely different. I can already see that it's completely different. Yeah. The empty seats below would see no occupied seats. Okay. Let me try to read the part 2 again, because is it inverted? What inverted? I don't understand. As soon as people start to arrive, you realize the mistake. First seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediate adjacent seats, consider the first seat in each of the directions. Okay, the leftmost empty seat would only see the empty seat below would see no occupied seats. Okay, so we shouldn't see any occupied seats here. 5 or more, 4 or more. I didn't see mistakes, like I didn't see any single mistake. But I'm pretty sure I made something extremely dumb. It's yet again like something very small, something very dumb. Okay, so here's the HW, so we iterate through all of these things. We discard when the row equals 0. So at least one of them has to be equal to 1 or minus 1. So then we move forward, and while this thing is within the accepted range and it's occupied, we increment the result and we will break out of the loop. If it's not, we could keep pushing that direction. If you see empty, you don't search for occupied. What are you talking about? Oh yeah, that's true. Yeah, that makes sense, thank you. Okay, so result 1. Otherwise, does it have a leaf? Yeah, it does have a leaf. We can actually do something like a switch case. Yeah. Yeah, I didn't think about that for some reason. Thank you so much. I'm already tired because this is my second problem, right, of today. And I'm not sure if I'll have time for the game development because of that, so probably we'll have to stop. So today might be. So if it's not occupied, we just break. And the default situation, else. Do we even need else? Maybe we do. Yeah. So that makes sense. Thank you so much. Okay, so that's already better. That's already better. Where do we have the echo? Where do we have the echo? So let's remove that echo because it takes too much time. Yeah, that should be the correct answer. To be fair, like, this problem is easier than the previous one, and it's a little bit too mundane, so I don't know. Yeah. There we go. Solved it in Nim. How about that? How about that? Isn't that epic? Isn't that goddamn epic? I think it's kind of epic. So let's remove some garbage and I'm gonna commit all of that. So git ignore. So what do we want to ignore? We want to ignore main. Right, we're gonna ignore main. And I'm gonna also do readme md. So day 11, and this one is gonna be like this. An anonymous user is gifting 5 tier 1 subs to Sodium community. Thank you. Thank you so much for gifting the subs, and everyone who got subs. X Zook Wise, Last Miles, Gay Lolo, Marian G, Plata Splunk. Welcome to our epic Advent of Code Club, I suppose. That's what we're doing these days. Nothing else. Alright, so solution in Nim, right? So what's going to be the next language, I wonder? What's going to be the next language? So the last more or less usable language for me that is left is probably Pascal. Because I pretty much wasted all of the usable languages right away. So you're kind of disappointing. All right, so what we need to do here, readme. So this is not what I wanted to do then. Where is my readme? Give me, okay, this is so dumb. I need a readme that is located in the 11th. Thank you, Emacs. Jesus Christ, why was it so difficult to do? Install Nim. Right, install Nim. And make sure Nim is available in path. Right. Just do make, and that should work. So that's essentially what it is. C# sounds like a cool idea. I'll think about that. Cool. So 11. Add solution for day 11 in Nim. Okay, cool. So, and all of the solutions are available here if anyone is interested. If anyone is interested, here they are. There we go. So, I wish I could do game development, but actually I'm a little bit tired already, so I think I'm gonna call it a day. I think I'm gonna go today. So the dynamic programming problem was actually kind of useful because it forced me to remember how to do dynamic programming, which is kind of cool. And I hope it was useful for people who got stuck on the 10th day. So, because yeah, that's how we're supposed to do that. You don't necessarily have to do that the way I did it, right, with the dynamic programming table and shit like that, but you can do that recursively with the memorization, right? So you don't really have to do it like that. It's just not really necessary. But just do a recursive version with memorization, and it will be, you know, fast enough for the advent of code. I wonder if you do recursion without memorization and let it run overnight, would you be able to actually find solution this way? It's kind of interesting. But you're definitely not going to be the first one who solves that problem. Yeah, that's for sure. Anyway, that's it for today, boys and girls. That's it for today. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow I'm gonna solve only one advent of code problem, and then I'm gonna continue with game development. Yeah, check out our schedule for more information on different projects I'm working on. Check out our WhatsApp channel where we archive all of the streams. This stream is gonna be there, but tomorrow we upload them on the next day. And also check out our Discord server for offline discussion with the community. So we also discuss advent of code there if anyone is interested, so feel free to join. And yeah, thanks everyone for watching. Love you all.